private passphrase there. Okay, so once you've logged in and you got to this page, what we'd like each of you to do is to create a slice, and you'll have to give your slice a unique name. And if you look on, can you just hid the part I want to show. All right, so where it says create slice here, we would like you to actually type in a name of your slice that you'd like to create. You can name it GEC19 and some suffix that you perhaps would like to add there, your initials or something like that. And then for this particular project, we'd like you to create it under the project, which is GEC19 project. So there's a drop-down menu here that if you clicked on it, it would actually list GEC19. So type in a slice name and GEC19, and then you hit create slice, and it will go off and create a slice for you. So this is the exact same operation that you would have done if you were using the Genie portal. And the Genie portal has a very similar mechanism where you click and you select the slice name and the project that you want to create it with, and then you hit create slice as well. So note that we can basically do all the same sorts of things here that you can do with the Genie portal. Once you've done that, you'll see a slice name appearing in the list up here. So maybe you want to go ahead and change back to the live view at this point. Okay, so here's an example of a whole series of slices and that we have. And your slice would have appeared, and you will note that it has several different columns. The first one identifies the RSpec, the topology that you're going to be using. The next one tells you which aggregates that you're going to create that RSpec on. And then we have a column here that tells you what status you currently have. Do you have resources? Do you have slivers in your slice? And yeah, okay. So do you have slivers that are part of your slice yet? At this point, yours should say that you have no RSpec and that you currently have no resources. All right, so here's the part where we need to get you started on actually adding resources to your slice. And the way we're going to do it is we're actually going to use a predefined RSpec that's been unbound. That is, it hasn't specified which nodes within an aggregate you're going to use. So what you're going to do is you're going to select, by clicking on the name here or wherever it is, you select and say you currently have no RSpec. And when you do that, it will pop up a list of RSpecs that you can choose from. You should see in there a list. It might be different than this particular list, but one of them that you should find in there is the public RSpec for this particular tutorial, the GEC19 RSpec for InstaGenie. And that's the one that you would pick. Now, you'll note that as you were mousing over these items, you actually can see the topology there. So for each of these RSpecs. Now, when you clicked on it, okay, here we go. So as you're moving over, you'll see on the right-hand side, it will describe the topology in a visual way for you, and also there's a description field that people will have typed in to describe what that topology is and who entered it, for example. Once you click on it, you say set that as the topology. It should now be entered into this box here as your topology. Now, if we went over here and clicked create slivers, this would go ahead and try to create the slivers for us. Now we'll go ahead and do this just for the fun of it. You'll note that it actually came up and said, this RSpec has not been bound to a particular aggregate yet. You need to do that. So it's giving us an error message, and we have to say OK. So at this point, we really need to bind it to an aggregate. And the way we do that is you click on the aggregate column here. We currently have no aggregate managers assigned. And so once you click on that, it will pop up a list for you of aggregates that you can use for assigning and creating this particular experiment. Each of you has been assigned a different aggregate, and we would like you to create your experiment on the aggregate that you were assigned. So if you were assigned the Kentucky InstaGenie rack, you would click on that checkbox, and then you would say set AMs for GEC19. Once you've done that, at that point, you can go ahead and say create slivers. And it's going to go off now, and it's actually going to start creating the topology, just like you would have done if you had done it through the portal. At this point, we're actually creating the topology, and you simply wait for the machines to be set up. And you'll note that it will continue to say create slivers here. At some point, it will actually change this, and it will say that you have resources and slivers reserved.
look like?
I like the third one, yes.
Yeah, once it's done, it should look like the third one that says has resources.
Okay, and after you've done that, then we'll actually have to take it through two more stages, what we call the initialized and the instrumentized stage, and I'll tell you about those in just a moment here. But if you have any questions about this, please ask the people walking around the room here, and they'll try to help you get set up. While we're waiting for our slices to be created, I'm going to tell you a little bit more about the Genie desktop. So we can go back to the slides here. Okay. All right, so let me tell you just a little bit about the Genie desktop while we're waiting for our slices to be created. So the Genie desktop actually does a whole lot of different things, and you perhaps did the starting Genie tutorial, getting started with Genie tutorial, and that tutorial probably introduced you to the Genie portal, which is a very useful tool, and you can do a good deal with that, and it's a very simple interface. The Genie desktop is sort of an alternate tool that you can use. It will actually take you through all the same stages of the Genie portal, plus it will do instrumentation. So in many ways, you could just simply use the Genie desktop as opposed to the Genie portal and actually be able to do your instrumentation as well. So here's a long list of things. Throughout the tutorial today, you'll actually be introduced to many of these different features of the Genie desktop, and so I'm not going to talk too much about them right now. Okay, so we've been through the login stage, and then you receive this welcome page and this slice list, and you've been through that and actually created a slice. All right, after we've initialized the Genie desktop, you'll actually ultimately be taken to a page where you can see visually your topology, and you'll be able to work with it. And so this is the area where we can now start selecting nodes and start to view various measurements that are being taken as part of the Genie desktop. Okay, so there's basically two phases after you've created your slices. So we're doing the creation of the slices. The next phase that we're going to engage in is what we call the initialization phase. And the initialization phase is going to add additional software onto some of the nodes in your topology so that we can control them, that you can SSH into them, that you can load files onto them, and be able to do basic setup characteristics of your slice. After that, there's an optional phase, which you don't have to do. The optional phase is a little bit more heavyweight. It takes more time to install. But this one will instrumentize your slice with software that will then automatically start to monitor and measure your experiment that's going on and provide graphs back to you, TCP performance graphs, IP graphs. And so if that's the type of thing that you'd like, you can add that on doing the instrumentized phase. In most cases, people would like to see this, so we do typically do that or recommend it. At the same time, it is a little bit more heavyweight operation. So basically, there's sort of three phases. One is to create your slice, which you've already done. The next phase is to initialize it so that you can upload software to it, you can run SSH commands to it, and then the third phase, of course, is the instrumentized phase. All right, so ultimately, when you've got all the way instrumentized, you can now select nodes in your topology, and you can show traffic graphs and that sort of thing for your slice. Okay, so one of the things that we tried to do in the Genie desktop was to come up with a unifying theme or way of interacting with it. And so the goal there was to make it relatively easy for you to visualize the data that's inside of in the measurement data that's coming from your slice. And we sort of came up with the abstraction that one of the things you typically do is you want to be able to point and click on nodes in your topology and be able to view the data that's part of them. So basically, there's two common things you like to do with a slice. You want to sort of select resources, visually typically, and then you want to apply an operation like show me the TCP graphs or show me the IP graphs, or maybe even just log into a particular node. So we modeled it after something that you're all familiar with. Is basically a file browser. A file browser, you can select a node or you can select multiple files, and you can say copy or move, or you can say delete. You can do the same sort of thing in the Genie desktop world. I can select several different nodes, and I could say, show me the TCP graphs for all of these nodes. Or I could say, log into all of these nodes. So the idea is very similar to a file browser. There's a couple different views that we give you of your different nodes in your topology. One is what we call the logical view. And the logical view is the view I just showed you earlier, where I have a logical topology. This is sort of logically what the topology looks like. It's 4 nodes, and in the Gemini world, we also add in what's called a global node, and the global node is where we collect all your measurement data, and that will be displayed there, and it's the one that's actually generating these graphs. So that's the logical view. We also have what we call the geographic view. The geographic view will actually show you a map of the United States, typically here, and the locations where your nodes are located. So if you actually want to see how are the nodes located across the United States, you can view that map as well. And again, all of these views, whether it's the logical view or the map view, you can still click on the nodes, select them, SSH into them, copy files to them. Any of those operations are possible. The list view is actually very useful if you have a very large topology, and particularly if the nodes would, in any of the views, would sort of pile on top of one another. List view is very nice in the sense that you can actually list out all your resources. It's just simply a list of the resources, and it's filterable, so that if you wanted to look for nodes of a particular type, or you just simply say, I want to see all the links in my topology, all the nodes in my topology. In that case, you could use the list view, and you can filter on that. And we'll give you an example of how to do that a little bit later. All right, so again, the unifying theme is that regardless of which of these views you're looking at your system, if you click on a node in the map view, it would be also highlighted in your topology view or be highlighted in your list view. Any one of them, you can select multiple nodes, and you can apply an operation. Okay, so it's really sort of modeled, again, after a file browser. So we're going to go ahead and do a little demonstration here at this point to show you what you'll be doing once you get to that point. So I'm going to ask Nasir to drive, and I'm just going to talk you through it. So, all right, so here's the Genie desktop, and you can see they have, in this case, we have several different slices that he's been working with. Let me tell you first a little bit about this front page that you can work with your slices here. We've actually done quite a bit of work here, and trying to make this a little bit easier to use. Each of these, every element on this page is basically clickable and has a different action that is applied to it. One you've already seen. You can click on any one of these and upload an RSpec to it, and we've added basically an RSpec database that now not only keeps track of what the RSpecs are and can load them, but also gives you a visual picture of the RSpec, a description of the RSpec. You can, in fact, change this picture. If you don't like this picture, you can go in and change that picture and draw your own picture of how you'd like your RSpec to be. That, particularly for very large topologies, you may want to have a different type of picture that shows there. And again, by clicking on any one of these, it would load it into the RSpec field, which you then can use to create your topology. You can also, there's a filter field up here. When you have lots and lots of RSpecs, we've shortened our list right now, but if you went to the Genie portal, for example, there's a very long list of RSpecs there. And if you wanted to search for a particular RSpec or something that has particular characteristics, you can type it into the filter field up there, and it will search all the titles and descriptions and come up with the RSpecs that match for you. So if you want to reduce your list. Let's go back to the table here. We also have added features now such that if your RSpec does not match up with the set of aggregates that you want to run it on, it will actually pop up an error message and say, this RSpec does not match with the set of aggregates, and we'll ask you to change your aggregates. But using this aggregate field here, you can click on the aggregate field, and you can select which racks, which other aggregates are out there that maybe aren't necessarily racks you want to run on. And you can do that through this interface. You can select multiple nodes. If you select multiple nodes and you only have a few, if you only have, for example, an RSpec that's unbound, it will come back and tell you you have an unbound RSpec. You can only run it on one of them. You don't want to run it on multiple of those. All right, so going back to the list here, this provides status information about your slice, so if you want to know what status it's in. Another feature we've added, particularly for resources that go away quickly, you may find that if you're using a rack and they only give you a reservation for 4 hours, that it's easy for your slice to time out, and that can be very frustrating. If you click on this field here, it will allow you to say, I would like you to auto-renew that for me. And so it will auto-renew an hour or two ahead of time. I don't remember what the exact time is.
1 hour before it's supposed to expire, it start auto-renewing for the next 6 hours.
Okay, so it will do an auto-renew for you. This is particularly useful for short-lived reservations that you're given. If you have a longer reservation, it doesn't necessarily help you that much. And it will only operate as long as you have this window open. So you can't just simply turn it on and say auto-renew, and it will keep auto-renewing forever. You never give up your slice that way. Okay, and the expiration time is also listed there. Once your slice has been created, the next step for you to do is to actually go ahead and initialize your slice. So that was the second phase I talked about earlier. So why don't we go ahead and initialize the one you just created there. If you have your slice came back, you should have initialized it at this point. And once you've initialized the slice, do we have any that are just initialized? Okay. Why don't you click on one of them? If you click on the name of the slice here, it will actually take you to the Genie desktop where you can start working with your slice. So clicking on this will bring up, in this case, it's been initialized. And at this point, we should see a visual picture of the topology. And then ultimately, we'll be able to log into some of the nodes or upload files to the nodes. So here's one of the things that you should be aware of. Several of the browsers will actually pop up warning messages about the certificates here, in which case you have to accept the self-signed certificate. That's quite normal. All right, so in this case, what's happened, this is the topology. It's been through the instrumentized phase, and, or excuse me, through the initialized phase. And we now have software running on the nodes that will allow us to access it, SSH into it, to upload files to it. And so if you click on the launcher icon over here, you'll see a set of things that we can do, which is relatively limited at this point. We can upload files, we can run commands on those nodes. And so, for example, if we wanted to SSH into one of these virtual machines here, I could click on it, just highlight it. You click on the Open SSH, and it will pop up a new tab here. And in this case, it will allow you to log in. Again, it might, depending on your browser, it may give you a warning message to accept a self-signed certificate. If we go back here, if you wanted to select these other two nodes, for example, you could go back and say Open SSH, and it will actually pop up two new tabs for you. And it will SSH you into both of those. And so you can quickly get to several of the nodes at the same time. Can we go back to the diagram? Okay. You can also run commands on several different nodes at the same time. There's a command option here, and by selecting the nodes up there, you select them, you say set selection of the nodes that you want to run, and then you type in a command here, for example, ls/temp, and you would get a listing of what's in the temp directory on each of them. And you simply say the run command, and it will come back and do this across all of your machines. So you could actually select your whole topology very quickly, and then run that command across all your machines. All right, so the color scheme doesn't work very well here, but you can see that it did an ls on the /temp directory. And lastly, we won't do it here, but you can say file upload. And the idea here behind file uploading is that you can actually take files that are on your local laptop, your local desktop, and you can upload them to the Genie desktop. From the Genie desktop, we will then upload them onto your experimental nodes. And the reason we do it in a two-stage fashion there is because oftentimes you will have created software that you would like to upload to the Genie desktop, and then depending on which slice you're using, you may want to reload that. So we keep a copy of it there, and you may send it off to different slices that you create, so you don't have to keep reloading it from your local desktop. So the first thing is you would choose some files locally, like you would in a normal browser. Then you would say copy those files to the Genie desktop, and from the Genie desktop, we copy them onto the selected nodes. So again, you would select the nodes in the topology and say, I'd like to copy those onto those nodes there. All right, so that's what you can do once the system is initialized. If you want to take it to the next step and you actually want to be able to view your graphs and your charts, we need to instrumentize your system, which is that last optional step. And in order to do that, we have to load on a great deal of software onto the global node and onto the what we call the measurement points, the experimental nodes. So if you haven't instrumentized your system, you can either go back to the original page and say instrumentize, or if you're working on the page that we were just on, it's still there, you'll note we actually have an instrumentized button there, a picture of looks like a cello. And you could click on that button and it would instrumentize your system by adding in the instrumentation and measurement software. So why don't we go to one that's been instrumentized, since it does take a little bit of time. So in this tutorial today, what we'd like you to do is keep an eye on what's going on there, and as your slice is created, initialize it and then instrumentize it once it's been created and initialized. Okay, so an instrumentized slice will now give you a whole new set of operations that you can run from the launcher. So if we now click on the launcher for this particular slice, you'll see that there's a larger set of things that we can do. One of the things that we can do is to do just passive graph measurements, which are to say, I'd like to see the traffic that's flying across my links, and this is traffic that's currently being sent across them for whatever purposes. So for example, I might say, I'd like to see passive graphs for VM3 and VM1 in this case. Okay, so clicking on passive graphs will actually pop up a window here with a list of the traffic that's been going back and forth across those. And it's predefined a couple of them for you, but you can go and change which graphs you want to show. So if you click on the graph, the graphing here, we're currently showing the CPU load, the TCP graphs, and link octets that are going back and forth across or between those two machines there. And so you'll see here that you can control these graphs in great detail by changing the chart size. There's a chart size slider up here, which will allow you to see them in more or less detail. Now you can see that well, you changed the ice. There we go. TCP graph would look a little better. Another thing that you can do with these graphs is that these graphs allow you to actually mouse over the graph itself to find out what the actual values are. So if you hover over one of the points there, it actually pops up a little window that describes what the value is. It's not showing up. I don't know why. It looks like it's trying to. So perhaps it shows up better on your browser, but you can see here that you can actually look at the exact values that are being displayed here. This is a moving graph. It's updated every 5 seconds, and it keeps moving from right to left, showing you typically the last 15 to 20 minutes, depending on the scale of your graph there. You can change which nodes that you want to monitor. The initial set are the ones that you clicked in the window, but you can, of course, go up here and change the node set here so that you only selected, if you want to click on the list of nodes there. Okay, right now we're seeing VM3. You could change that to VM0, for example, and apply those configurations. And once you apply that configuration, it's at the top. To the right. Okay, if you apply the configuration there, you'll now see these are actually showing it's for VM0 as opposed to VM3, which was showing earlier. So you can change which graphs that you want to show. This is a more powerful graphing tool than what we used to have, although we still have our older graphing tool there as well. And so let's go back and show the older one, as this one gives you a nice snapshot, but not quite as much control over the system. So if you go here, you'll see that we have things called Passive Graphs Lite. And Passive Graphs Lite pops up, and it says, okay, of the ones that are checked over here, what graphs do you want to see? And we've selected CPU, ICMP, and IP traffic here. And it immediately pops these up in a very small format. So if you want to get just a quick sort of dashboard overview of what's going on with each of these things, you can see it. And if you mouse over them, it will actually pop up a larger view of the graph for you. And these are going to be moving from right to left, showing you. But you cannot, in this case, you can't go take a look at individual values. You can't change the scale. This is all predefined. But it gives you a very nice dashboard look of what's going on inside your topology. We've been selecting nodes. You can also select links. So you could pick out a link, and you could say, I would like to look at data going across that link. In this case, you might say passive graphs and say that I'd like to look at the link packets going across that. There's no CPU or graphs there, so you say add graphs. Again, in this case, you're looking at the actual traffic going back and forth, probably some sort of ping packets in this case. All right, so that's sort of the basic graphing that you have available to you in the Genie desktop. And in just a moment, I'll actually have Ezra come up and tell you a little bit more about the active measurements that you can do. So if you want to actually instrumentize and write your own events that you want to capture, there's a very powerful mechanism inside of the Genie desktop combined with Gemini in order to be able to do that. Another couple things that we should point out are some of these just options back in the Genie desktop for the different views. I'd like to show them the map view and the list view. So what we saw earlier was the topology view. Here's the geographic map view. If you pop that up, it will actually show you how things are located. In this case, we're actually running on a single rack, so all the nodes would have appeared exactly in the same geographic location. If you hit collapse there on the top of that map, it will actually show you that they're actually, in fact, all sitting on top of each other. That's not a very interesting view, so you can use the collapse and expand button to see your topology if it, in fact, is at the same location. Another thing you can do is with the list view here, you can select nodes here. So you select VM3 here. It appears it's selected over in the map view as well. You can select any one of them. If you've got a very long list of resources, you can go into the filter box here and you can start to say, I'd like to automatically select certain types of services. So in this case, it's looking for anything that starts with the term VM. So if you had a set of resources that were all named the same way, you might select them this way. And then, again, you can apply an operation. So you could have said, I would like to see the graphs for those particular ones, or I'd like to log into them. Right, so that's the map view and then also the geographic view, or the list view. Another feature that we've added more recently is for you to be able to change some of your settings. You can actually add in additional modules. And so if you look at there's a settings tab here, and you'll note here that this is the set of operations that pop up for us to be able to apply the actions. There's actually a larger set of operations that we have available to you. One of them is to actually see active graphs, and this is the one Ezra will demonstrate in just a moment, about how you can actually do active tracking of data and generating flows that represent the type of events that you'd like to track. Another one is we actually do have net flow capabilities, so if you want to see whether you're tracking HTTP traffic or particular traffic on different ports, you can actually add in a net flows graph there, and that will give you detailed information about the net flows graph. And there are additional modules. The entire system is modular, and you can use plugins to add additional features to the system. We have a couple of them in development right now. If you actually really love your RSpec and you love the topology and you'd like to use this and save it as a public one or a private one, we have some buttons down here now that will allow you to actually say, I want to save this topology and add it to the list of public, or you may decide that you only want it to be private to yourself and only available to you. You can save it, and at that point, it will be available. If you actually have drawn a picture of it how you like, you can say that thumbnail, that will be the thumbnail that actually appears when you're looking at the list of RSpecs that you can choose from. All right, so that's all into the settings tab. All right. Okay. One last thing I guess we should mention about the slice view here. There's checkboxes on the left-hand side, much like was the case with the Genie desktop where you can select a whole bunch of nodes and apply an operation. The same thing's true of slices. Sometimes you want to work with slices in the aggregate. So you can actually select any set of number of slices here and you can apply an operation. And there's a set of, this is drop-down menu here, gives you a set of different operations that you may apply to a slice. And once you've decided which one you want to do, you can apply that action. So you could, in fact, create a whole bunch of slices at the same time. You can then say, I want to initialize them all at the same time, or you may want to instrumentize them at the same time. You can examine their RSpecs and take a look at that. And if your list of slices becomes too long, you may, in fact, check some of them and say, I only want to show the checked ones. This becomes particularly important if you end up in a group that has lots and lots of slices, and that happens quite frequently. The other thing I should show you about the slice page is that there's a select project at the top. You may be in multiple projects. I know some of you were in as many as 6 projects. You can filter, again, based on the project that you're part of. And this will, again, limit the list here. At all times, on the right-hand side, it will tell you what we think is the next thing for you to do. You either need to initialize, instrumentize, or if you haven't created any resources, we suggest you use FLAC to create the resources, but if you want to use an RSpec, you can do that as well. Okay, so I think at this point, I'd like to first sort of find out how many people have are past the initialize and into the instrumentized phase. Okay, so most people are. How many of you are done instrumentizing? Oh, several of you. Okay, so then let me go ahead without further ado, and can we take them to the web page where they have the exercises? Okay, so there's a web page here that we've created, and it should be on the document that you received. It's the Genie Wiki, Gemini tutorial GEC19. And this actually has a series of exercises that you can go through to learn how to use the Genie desktop. And if you go down to the bottom where it says Start Experiments, it gives you a set of tasks here that you can move through. And the first 4 get you logged in. You've really kind of already gone through number 1, getting logged in, initializing and instrumentizing. So you could sort of pick up with the second one there. Ezra, do you want to first go ahead and give a description of the last one right now, or do you want to wait a little bit and let them get started with the? I will do it now, and we can just help people go through the exercise. Okay, all right. So if you want to get started, you can kind of do this. Ezra will tell you a little bit about this fifth one, which talks about the active probing and active measurements.
There we go. So I just wanted to spend a few minutes talking a bit about what Jim just mentioned, the last part of the tutorial exercises, doing some active measurements that involve using our measurement collector called Blip and some of the measurement archive that is instantiated in the slice. So you can perform active bandwidth and latency measurements, as well as instrumentize or instrument applications that you might be interested in running over your experiment. So let me quickly bring this up. And this is really a high-level picture of some of the additional services that are installed in your experimental slice when you instrumentize it with Gemini. And what you can see here is that in this box, it represents the user slice. You might have a number of PC resources in it. And one of the things that we install by default is our measurement collector called Blip. It's basically an agent that runs. By default, it collects passive measurements, but it also provides as an interface to UNIS, which is our topology and measurement metadata store that allows us to have a complete representation of your slice topology, as well as measurement configuration, and track the metadata about which metrics and which passive and active measurements you're currently running within your slice. So Blip is what actually realizes the measurements. UNIS is a global service that tracks the topology and associates the measurement metadata with what you're collecting. And all the measurement agents report their probe data to a measurement store that is a service that runs on the global node in that slice. So remember, you have this dedicated node that gets brought up automatically when you instrumentize with Gemini. And on that global node, there are a number of services that provide visualization, for charting, as well as measurement collection and sort of orchestration for the measurements that happen in your slice. And of course, the global node interacts with the Genie desktop, as was just shown. And the Genie desktop has the task of also informing UNIS. So when you actually create those RSpecs in your instrumentized slice, it converts the manifests into a representation that UNIS stores. And then all the probes inside the slice use that representation to track active measurements and metadata about the measurements. And then just to note that in the Genie desktop, there is an archive button. So all of the passive measurements and all the information about your slice that's collected by default is sent to an archive service, iRODS, and that includes all of the measurement store data that's been collected on the global node as well. So if you have a bunch of long-running experiments and you have a lot of active probes, all of that information is dumped and saved off for you for later analysis. Okay, so how do we actually access this? I just want to give a brief overview of where you go to get to the active measurement configuration page and how you might actually configure some of these probes. So right here I have my Genie desktop page. Let me make this a little bit bigger. And you can see I have an instrumentized slice. I will go to the Genie desktop. And hopefully the wireless doesn't flake out on me again, but just give it a little time. There must be a dead zone around these podiums because I just tried it over there and it worked fine. I don't understand. But all right. I will try the wire. Well, I don't have my adapter. There we go. It loaded. So one thing you can do is, well, first of all, I can also bring up that active module that Jim just mentioned, and that gives us a view from the desktop of the active measurements that are being run in the slice. And I already have some configured so we can see what those look like. So when you go to the slice module settings by clicking on this gear icon, you can drag and drop the various modules that are available on the Genie desktop over to the configuration for this slice. And I already had the active graphs module saved. So when I click on a node, I can then activate those active graphs and get some real-time updates in this window. So let's see what's going on here. So in this case, I can also take a look at, for instance, active bandwidth probes that might be running. I'll take a look at those VMs, do a live update, and see what's happening here. So you can see that there's some, on VM0, there's some CPU utilization spikes, and we can see that there are active bandwidth tests that are currently being collected. So those all show up from this nice active graph interface where you can get both the passive and active measurements. And we're expanding this to be able to pull out any additional active probes that might be configured in Blip in the PSConfig interface, which I'm about to show. So I just wanted to demonstrate that you can actually get to that data from these modules as well. So to actually get to the page where we configure these, you go to this Gemini GN button, and there's a PSConfig button that shows up in this pane. You click on that. You do have to have a node selected. Right. And you'll be brought to this page, which is derived from the Persona toolkit. We've modified it to take advantage of the new services that we're now running within the instrumentized slice. And you can see that you get a summary of, in this case, the two Blip services and the measurement store that's running on the global node. I'll make this a little bigger again. And you can manage Blip, turn it on and off, depending if you decide you don't want it running on a particular node for any reason. So you have configuration options to do that. And I really wish I had a wired connection. All right, so there's just the option to turn services on and off. But what we're interested in is actually scheduling some Blip tests. And I'll just demonstrate quickly what I have currently selected for some of these nodes. So in this case, I already have a ping probe running which will ping from one node to another, as well as a netlogger probe that will allow you to instrument a particular application running in your slice. And let's see, on VM0, I have an iPerf probe, so to do bandwidth testing between nodes. And you can see that what happens is when you run a test and it's successfully started reporting data and it registers metadata with Unis and starts pushing data to the measurement store, these drop-downs are populated with all the different event types that are collected for that particular probe. So for ping probes, there are 2 event types that we currently report. Those are round trip time and time to live. And let's see if this is going to chart for us. For some reason, I'm not getting data back. I swear, I just tried this a moment ago. But you will typically see data being pulled from the measurement store that's running on the slice. And you'll have another representation here that you can bring up multiple windows that run separately from the main browser instance. Lets you view the currently collected data. And I'm not sure why it's not reporting now. We saw it just reporting over on the other interface. I'm not sure if my Wi-Fi is acting up or what, but I just want to give you one more demonstration that shows where you can actually input the parameters for the various probes. So if you, for instance, click on the netlogger probe, you can specify a description, time between when you actually start collecting data from the file that's being collected on your node, which file you're actually looking at, how many collections to aggregate within the measurement collector before it gets pushed to the measurement store. So you have a number of settings that you can configure for each probe. Obviously, each type of probe is going to have different configuration options. Time between tests for the ping and bandwidth probes, so you can figure out a schedule for them. And then various properties, again, for the different types of active probes you can configure. And you can drag and drop or use these buttons to select the nodes that you're interested in actually running the probes to. Okay, so all of that is described in the exercise, advanced instrumentation with netlogger and blip, and you can give that a try. It's the last 3 pages of the tutorial, and I encourage you to give it a try. The last thing I wanted to mention is that what we've been working on lately is the ability for blip to do measurement scheduling within the slices. So we have developed this agent called Helm. So it's basically a controller. It's at the helm controlling the distributed blip services that run on measurements without contention. So you might have a use case where you want to have a bunch of shared resources that you're trying to measure across, and you don't want, obviously, to have bandwidth probes running across those shared resources at the same time. So what a Helm controller does is basically discover where all the services are, and it runs some initial set of probes to figure out where the shared resources are, updates the measurement objects in Unis to determine what type of schedule it can then perform. So you can have a goal, for instance, to set up a full mesh of tests with the condition that none of the tests will intersect over shared resources. And the idea here, of course, that the Helm controller will run on the global node and basically manage the schedule and update them in real time to the blip instances that will collect them. So this is something that we've prototyped it, and it's working, and we actually have the developers here in the room. So for anyone who's interested in looking at how you can configure the agents to do a certain set of tasks that are running on the nodes themselves, and how to access the raw data on the measurement store, if anyone's interested in doing that, we can form a little circle and talk about the details of how you would go about that process. So feel free to ask questions about that. I just wanted to mention. All right, so I think that's all I had about the active measurements. Again, give the active measurement exercises a try, and it'd be great to see how they work in your slices. Thanks.